passes over Niagara Falls' 160-foot drop every second. 2/3 of North America's fresh water passes through its American and Canadian falls. The Niagara River in upstate New York feeds Niagara Falls, which is located between Lake Erie and Lake Ontario. Today, the Niagara Power Project that harnesses just 1/3 of the fall's hydroelectric potential is the 5th largest electricity producer in the United States, as well as the largest electricity producer in New York State.
This plant, when it was built, was the largest in the free world.
Consisting of the Robert Moses Power Plant and Lewiston Pump Generating Plant, the Niagara Power Project generates enough electricity to continuously light 24 million 100-watt light bulbs.
It was truly a magnificent feat to complete this facility in a little over 3 years. Houses had to be relocated, bridges had to be built, highways had to be relocated, as well as railroad tracks. The amount of excavation that went on, I believe it's something on the order of 25 million cubic yards. I mean, just the numbers are staggering.
While the Niagara Power Project utilizes state-of-the-art technology, the idea of harnessing the power of Niagara Falls and the Niagara River was almost always ahead of the existing technology. Niagara Falls was formed nearly 12,000 years ago when the North American ice sheet started to recede and formed one giant freshwater lake called Lundy, which now consists of 4 of the Great Lakes. The runoff from Lake Lundy formed the basin of a lower lake, which is now known as Lake Ontario, the 5th of the Great Lakes. As vast amounts of water from the upper lake began spilling into this basin, Niagara Falls was born.
Thousands of years ago, I would think that when people saw the falls, they thought of it as being a source of power that was religious. Maybe they thought of it as being a manifestation of one of their spirits or gods. And the first missionaries who came to this area also thought that the falls was one of the works of God. It showed his handiwork, his might, that he was able to conceive of something so awesome and create it.
The missionaries may have stood back, admired, and revered the falls, but others wanted to utilize the power.
In the mid-1600s, a Frenchman by the name of Jean Kerr built a mill above the American Falls, near the American Rapids, and he used this mill to cut lumber. In fact, this mill was very useful at that time because it was the time of the French and Indian War, and they used the power from this mill to cut planks for warships.
Even though Jean Kerr's idea spurred interest in the area, little would be accomplished for 150 years.
Niagara Falls was the most impressive, awesome, and sublime power source in the world. And in people's imagination, there was no other place that conveyed power to the extent of Niagara Falls. And everyone wanted to put this to use.
By 1805, New York State officials were granting unlimited water diversion rights to various private power ventures. At a public auction, Judge Augustus Porter and his brother Peter purchased water rights to the American Eastern Rapids above and below the falls.
It was basically the same problem they had hundreds of years earlier. There just wasn't sufficient technology to utilize all the power that could be generated by the falls. Smaller falls were more than sufficient, and they were much easier to harness. Again, the Porter family offered free land to build a canal to anyone who would be interested, and they weren't really able to attract any investors.
Various engineers and entrepreneurs tried to tame Niagara, none successfully. Until 1860, when the Niagara Falls Hydraulic Power and Manufacturing Company built a canal 35 feet wide and 8 feet deep. The canal transported water from the Niagara River above the falls to the mills below the falls, but failed to attract businesses. Soon after the canal was completed, the company went bankrupt. Entrepreneur Horace Day took over and for the next 17 years worked sporadically on the canal, deepening it, widening it, and lengthening it. But he had only one customer and also went bankrupt in 1877. Hydropower was first used to produce electricity at a plant on the Fox River near Appleton, Wisconsin on September 30th, 1882. But it wasn't until a visionary European manufacturer purchased Horace Day's canal that man would again attempt to utilize Niagara Falls' vast power. Jacob Scholkopf was a German immigrant who came to Buffalo in the mid-1850s. He was an affluent tanner who saw a good business opportunity.
After he purchased the canal, he built a few mills there. He attracted the interest of other mill owners from Buffalo. Before long, there were grain mills there and pulp mills and other small manufacturing outfits, which was all well and fine, but even so, this still represented sort of an old way of harnessing power. Now, in the 1880s, an engineer who worked for the Erie Canal, Thomas Evershed, put forth a proposal that kind of was a bridge between what Scholkopf did and what would be done at the Niagara Falls Power Company. He proposed building an inlet canal off the upper river, which would in turn have individual mills located along it. But at a point above the falls, this canal would suddenly end and the water would be emptied underneath the city. That's the part that was kind of a unique take on it, the idea of having a tail race tunnel built under the city. This concept drew a lot of interest.
Some of the nation's leading financiers lined up behind Evershed's plan and were willing to invest their capital in it. These included Vanderbilt's, Astor's, Morgan's, Edward Dean Adams, who later became the president of the Niagara Falls Power Company and its first historian. Big money behind it.
Evershed's tunnel would generate 200,000 horsepower at the falls by turning gigantic water wheels. The tunnel would be 2 miles long and at least 160 feet deep.
The problem with the Evershed plan was that it was rooted in the past. Evershed's plan wound up being transformed from a mill-over-wheel blueprint to a plan where power was distributed over long distances. Only when power could be efficiently distributed over long distances would the Niagara Falls Power Project be a legitimate and viable venture. And this process involved the entire international engineering community.
And it would involve electricity. The International Niagara Commission, made up of Niagara's most influential citizens, set up a contest that attracted entries from the world's leading engineers, all trying to harness the power of the falls, and then send that power over long distances. Thomas Edison's direct current method of transmitting electricity was looked upon as a godsend for the power-hungry populace. But a mad genius from Croatia was about to threaten Edison's title as the world's premier electrical scientist. The year was 1884 when Croatian-born Nikola Tesla arrived in the United States with only 4 cents, a book of poetry, and a reference letter from a friend of Thomas Edison's. Still, Tesla was an up-and-coming scientist, known for his ability to concoct ideas solely in his mind and turn them from concepts to reality without even putting them on paper. He had worked for a European company headed by Edison and came to America to seek fame and fortune by taming the Great Falls of Niagara.
The greatest names in engineering, Thomas Edison, Nikola Tesla, they all envisioned being the ones to harness the tremendous power potential of Niagara Falls. And this became a dream. Whoever could harness Niagara was going to make their fortune as well as make their legend.
At this point, only Edison's direct current method had successfully transmitted electricity. But even the great inventor's plan had its shortcomings.
Edison's direct current only sent power within a very limited range. Tesla, who developed alternating current, came up with a system that could send power over vast distances. And each believed that they had the correct system for sending power from Niagara Falls and harnessing it. And each wanted to be the first to do it, of course.
Besides only transmitting very short distances, direct current flows through a conductor in one direction with a steady flow of charges, while alternating current constantly reverses itself. This reversal pushes the current backward and forward through the wires connecting to the power source. The conflict was so intense that Edison and his supporters went around the country conducting a smear campaign against Tesla and his alternating current method of transmitting electricity.
Thomas Edison initiated what became known as the War of the Currents. Edison was so determined to stave off the onslaught of AC that he began to begin a PR campaign to basically scare people. What he did is he began to call alternating current the executioner's current, the killing current. Edison himself, too, staged experiments with alternating current. In these experiments, he electrocuted dogs, cats, even an elephant. This PR campaign didn't succeed.
The ability of Tesla's alternating current to transmit electricity great distances would allow the power companies to distribute more of the energy produced by the falls. It was this trait that convinced the Niagara Falls Power Company Board of Directors to award Tesla and George Westinghouse, Tesla's financier, the contract to build the first two generators at Niagara. The Niagara Falls Power Company moved ahead with construction of its mammoth underground tunnel. That task would take from 1892 to 1895. Using dynamite, pneumatically powered drills, steam shovels, and pickaxes, more than 1,000 workers labored around the clock during the 3-year project to build a 6,700-foot-long, 21-foot-high, and 18-foot-wide tunnel dubbed the greatest hydraulic tunnel in the world. Workers displaced 300,000 tons of rocks. 20 million bricks lined the tunnel, and 2.5 million feet of oak and yellow pine were used to shore it up. Water drawn from the canal would move through the forebays, or intake reservoirs, and into the penstocks, large vertical pipes about 8 feet in diameter, before entering the turbines. Once there, the water would spin a gigantic metal wheel, and then move up a 160-foot-long shaft that went up to the generator, which was located on the main floor of the powerhouse. The canal would produce 100,000 horsepower of electricity. Company executives were relieved that only 28 workers died during the course of the construction. The hydraulic canal was completed in 1893. Workers cut out a gigantic groove in the riverbank about 180 feet deep where the wheel pits were located. The wheel pits were, in essence, the basement of the powerhouse. During the summer of 1894, huge electrically powered cranes lowered the massive 29-ton double turbines, the largest in the world, into the wheel pits. The wheel pits were built into the ground, then flooring was filled in over the turbines and wheel pits. The powerhouse was built over that flooring. That was the challenge for architect Stanford White, who was called in to build a powerhouse capable of delivering a much more modest 15,000 horsepower.
The Niagara Falls Power Company powerhouse was far different than any other power plant in the country. Most power plants were makeshift structures, very unsightly. There were coal piles and ash heaps to the sides of them. They were grimy places. They were dangerous places.
Edward Dean Adams was hand-picked by Niagara Falls Power Company board member J.P. Morgan to run the company and oversee the construction of this grand powerhouse.
Edward Dean Adams said he wanted this place, as he put it, to inspire awe. He wanted people to look at it and to think, wow, something really important's happening there. And I like to compare it to being almost like a technological cathedral. It's a place that's built in a very grand style because something very important, something very unique was taking place there. Now it's become commonplace to us, but back then it was something very, very impressive.
The powerhouse was a work in progress. Originally 140 feet long, by 1903 it eventually grew to 450 feet long and consisted of 11 generators. The renowned architecture firm of McKim, Mead & White designed the switchboard control panel with Italian marble around the steps. Other interior components of the powerhouse were impressive enough to move great writers of the time.
The powerhouse, of course, housed the Niagara dynamos, and really what the steam locomotive was to the steam era, the dynamo was to the electric age. This was the mystical power source, and these whirling structures inside the powerhouse had a capability of 5,000 horsepower, which today wouldn't be very much, but back in this era, a machine of 100 horsepower was considered quite large. These mystical dynamos were remarkable really for the fact that they were so unremarkable. The writer H.G. Wells talked about them as slumbering black monsters and big whirling tops.
Water enters the turbines. A shaft connects the turbine to a rotor, which is part of the generator. As the turbine spins below the generator, it turns the shaft and rotor. To produce electricity, the generator needs magnets and copper wiring. The magnets are affixed to the rotor's rim. The rim sits inside the stator, which surrounds the rotor with almost 400 copper coils. The rotor spins inside the stator, producing electricity in the copper coils. Even with stunning architecture and a nod to Niagara's past, as well as a glimpse into the future, Niagara's hydroelectric power plants didn't fully capture the imagination of the public until 1901. The Pan American Exposition ran for 6 months at the Buffalo Fairgrounds, only 20 miles from Niagara Falls. The highlight of the expo was the first long-distance transmission of electricity, thanks entirely to power produced from the falls. This display of power would forever alter the future of Niagara Falls. On the same day he visited the Niagara Falls powerhouses, President William McKinley was fatally wounded in Buffalo. Niagara Power will return on Modern Marvels. Niagara Power Companies were able to attract all kinds of industries to Niagara with cheap electricity and the promise of free land and housing for their employees.
In the 1890s, once the Niagara Falls Power Company's power project was underway, companies in different parts of the nation heard about this and they thought, well, maybe we should look into Niagara Falls. There were, of course, some small factories in Niagara Falls, but nothing very large scale, nothing really revolutionary as far as its industrial process. One of the first ones to come to Niagara Falls was the Pittsburgh Reduction Company. They needed lots of power and cheap power to create a product.
The Pittsburgh Reduction Company, later renamed Alcoa, was just one of many companies that welcomed the move to Niagara Falls. Edward Atchison's graphite company, which produced carborundum, also took advantage of Niagara's cheap power. But in Atchison's case, the move was made over the objections of his investors.
When he announced to his investors that he was going to move his plant to Niagara Falls, some were so outraged and thought this was such a wild idea that they left the company and basically took their toys home with them. They just pulled out of the company. But within the next few years, Atchison showed what a wise choice it was. The carborundum company mushroomed. It became a gigantic industry.
The turn of the century saw Niagara Falls become a mecca as paper mills, cereal companies like Henry Perky's Shredded Wheat Biscuit Company and Camp Gillette's Safety Razor Company appeared on both sides of the border. Interest in utilizing the power of the falls had always existed on the Canadian side, but until the success of the American efforts was evident, the Canadians were content to take a wait-and-see attitude. Once they were convinced of Niagara's promise, Canadian interests soared.
There were three power companies developing the potential of Niagara Falls on the Canadian side. There was the Toronto Power Company, or otherwise known as the Electrical Development Company, which was a private Canadian company. They were established to develop power in Niagara Falls and transmit it to Toronto. The other company, Canadian Niagara, was a U.S. company, and they are still here today. And the third company was Ontario Power, which was again a private American company that was developing their plant at the base of the falls. All three of these plants were under construction at the same time and all produced power, their first power around 1905, 1906.
The Canadian wonder of Niagara Falls, which
desired on the part of the government to preserve the beauty of the falls and preserve it as a free tourist attraction. Certainly one of the fears of the Parks Commission was having industrial plants in the park. So when you see these older plants, their architecture is really quite attractive. The developers of the companies, the power plants, wanted to make sure that they could demonstrate that yes, you could build an attractive power plant and have it at the falls without detracting from the natural beauty.
Since 1892, the Edward Dean Adams Station, previously known as Powerhouse Number 1, has operated on the American side of the falls. Then, in 1900, Canadian Niagara started construction on this plant, the William Rankin Generating Station, which is still in use today. It was the first power plant built on the Canadian side of the falls, and in grandeur followed the lead of the American power plants.
Architecturally, the building itself stands out as a marvel of its time. The marble was imported from Italy. The clay tiles that were used from the roof were built to rigid structure. Everything was overbuilt with the aesthetics in mind also. So there were certain criteria that were required to build this plant. You would really never know that it is a hydroelectric plant because you do see a nice calming effect of what looks like a pond in front of a building, but really that is the forebay.
By 1905, the Niagara Falls Power Company had 2 power stations in operation, while 3 existed on the Canadian side.
There was so much power development going on at Niagara Falls, so many competing interests, and also apparently such a demand for power that a lot of people in the U.S. and Canada became concerned that perhaps too much water would be diverted from the river and the falls would practically fade into oblivion.
The United States and Canada signed an international treaty in 1907 that strictly regulated the amount of water that could be diverted by the 2 countries. Power companies that were already established divided up each nation's portion.
I myself think if that treaty had not been signed, most of the water would indeed be going through penstocks instead of over the falls, because each of the power companies had plans for further expansion, every single one. And as time progressed, the demand for power did grow, and I'm sure they would have found a market for it.
By 1918, the demand for more power did grow, but not due to more industry coming to Niagara. With the advent of World War I, international treaty regulations were eased, and the power companies were able to increase their energy output. At the newly constructed American-based Sholkoff plant, the war effort brought about significant achievements in power plant production. including moving the power plant about 8 miles farther away from the falls.
It used a head of water. In other words, the water dropped from a greater height than it did at the Niagara Falls Power Company's power station. That in itself enabled the power station to generate more power, but also larger turbines had been designed by then. Turbines that could withstand the force of that type of drop, that velocity of waterfall. The generators were built directly on top of the turbines. They weren't connected by a long vertical shaft. They were very close in placement. That, along with a lot of other engineering innovations, made it possible for that power station to generate huge amounts of power, again making it the world's leading power generator.
On the Canadian side, creative problem-solving and improving technology were taking place. The Queenston, Ontario power plant, owned by Ontario Hydro, actually called for building a canal that would reverse the flow of the Welland River, about 1 mile above the Niagara River and Niagara Falls.
The canal certainly was an engineering feat. The construction started in 1917, and it wasn't completed until 1921. So we're looking at a period of 4 years, intensive effort, horsepower, shovel power, human power, and we see some of the photographs, blasting and very real, large, old steam shovels powered by steam. So the labor was intensive, but again, it was the state-of-the-art construction techniques of the day.
When completed, the Queenston Canal was nearly 13 miles long and could carry up to 600 cubic meters of water per second. By 1921, a massive power plant was needed to house and harness the river's energy.
It was a major development, seen as something that was so big that construction was actually put to a public referendum. And that referendum was approved in New Year's Day 1917. The plant would have 10 generators. The total capacity of the plant would be 450,000 kilowatts. It was seen as supplying the electric power to the province of Ontario to the turn of the century. When it was completed in 1925, it was indeed the largest power plant in the world.
While the Niagara power plants continued to grow in size, the technologies developed during World War I would change Niagara's role as the world's leading hydroelectricity producer. In fact, mammoth hydroelectric power plants larger than anything seen at Niagara started cropping up in New York City, Chicago, and Arizona. These new power plants combined large building sites, upgraded technology, and government involvement, practically making Niagara's turn-of-the-century powerhouses obsolete. In early 1949, Alcoa, at one time the world's largest user of electricity, shut down its Niagara plant and moved south. It would take a tragedy for Niagara to regain its place as the leader of hydroelectric power. In the late 1940s, the United States and Canada anticipated the expiration of the treaty that regulated the amount of water each country could use for hydroelectric power. Both countries saw this as an opportunity to expand their take of the Niagara River, thus increasing their energy output. The treaty in place since 1907 allowed Canada to draw 56,500 cubic feet of water per second from the falls, while the United States could draw 32,500 cubic feet of water a second. The new treaty signed in September 1950 declared that once the scenic protection of the falls was guaranteed, all the water in the Niagara River could be used to develop power. This meant that not less than 100,000 cubic feet of water per second must be allowed to flow over the American and Canadian falls during the summer months, while the flow would be reduced to 50,000 cubic feet between November and April. Only 4 days after the treaty was signed, Ontario Hydro had plans underway for Sir Adam Beck's Station Number 2.
Construction started in 1950. The diversion of water from above the falls to the power plants downstream involved the construction of two tunnels approximately 40 feet in diameter each. The construction of the tunnels was essentially a mining technique, drill and blast, and pour concrete on the spot. There was considerable disruption throughout the city of Niagara Falls over a period of 4 years, where material would be brought to the surface through various service shafts throughout the city.
The Beck Station number 2 was built only a few yards upstream from Beck Station number 1. When completed, it produced 700,000 horsepower, and it cost $157 million. On the American side, the New York State Power Authority wanted to follow Canada's lead and build a state-of-the-art plant. But after 6 years of political wrangling, the Power Authority's plans were still on the drawing board. That is, until a power plant collapsed on the American side of the Niagara Gorge on June 7th, 1956. The 1924 Sholkoff plant was the largest electricity provider for the eastern seaboard. 40 years after the accident, there is still no single explanation for the Sholkoff disaster, but a major factor appears to be connected to an earthquake 10 years earlier.
Back in the early 40s, I remember being in the lower part of the last unit they built, making measurements, and there was a big indication that there was a lot of deformation down in there.
There were also several leaks along the back wall of the powerhouse, but it was several years before these problems grew larger and needed to be addressed.
So that sometime in the early 1956, it was decided that we were going to try and stop those leaks. And we were going to drill a number of holes in the high bank and pump grout down these holes to try and seal up this leakage.
A team of engineers drilled holes 300 feet deep in order to reach the forebay's concrete walls, which had developed fissures. There were 3 people at the power plant when the accident occurred. Machinist Norman Draper was the only fatality. Since the early 1950s, a consortium of 5 power companies had been negotiating to build a new power station near Niagara University to replace the outdated Sholkoff plant. The Sholkoff disaster was the impetus for the U.S. government to get involved. On August 21, 1957, President Dwight Eisenhower signed the Niagara Redevelopment Act, which allowed the New York Power Authority to fully exploit the United States share of the Niagara River's hydroelectric power potential. It would become the largest engineering project in the United States at that time, and one of the largest in the world. The New York Power Authority purchased 200 acres of land from Niagara University to build the new power plant.
Initially, there was a lot of opposition to the idea of the government operating a power station. But nonetheless, the fact that there was an emergency made people feel that things had to happen quickly.
The Power Authority started construction of its tunnel even though the state agency was embroiled in a lengthy battle with the Tuscarora Indians, who inhabited the 6,200 acres of land next to the land purchased by the Power Authority. While negotiations between the Tuscarora and Power Authority dragged on, construction also started on the Robert Moses plant in the spring of 1958.
I can remember the blasting. We have cracks in our walls in our home as a result of the blasting.
More than 100,000 workers braved bitter winters and humid summers to meet the state's deadline. 8 temporary bridges were constructed and 5 million yards of earth and rock had to be removed. Construction of the power plant forced detours of streets, roads, and highways. Even houses were placed on trailers and moved 3 miles away to a newly erected subdivision. While all this was going on, the battle between the Tuscarora and the state of New York, which oversaw the Power Authority, continued all the way to the United States Supreme Court. Finally, on March 7, 1960, the court handed down its decision. By a 6-3 vote, the court held that the tribe had never acquired their land by treaty, but by gift and purchase. This meant they had no legal right to receive any compensation for the land. With that decision, the Power Authority, under the leadership of its chairman, Robert Moses, moved swiftly to make their 1961 deadline.
The construction of the Robert Moses power plant was a gigantic undertaking. There were massive dump trucks and massive cranes and bulldozers and explosives. Nonetheless, of course, it was a civil engineering feat. The construction of the power station called not only for a portion of the gorge wall to be removed to enable the placement of a power station there, but it also required the excavation of a deep forebay, and also it called for 2 tunnels to be dug under the city of Niagara Falls to be blasted away.
More than 3.5 million cubic yards of concrete was poured. Almost 10 million cubic yards of earth was excavated, and 24.5 million cubic yards of rock was displaced during the 3-year construction period.
Construction on that site went on night and day. It never really stopped. They used gigantic spotlights and just kept blasting rock and pouring concrete and placing steel, and it's a big venture.
On January 28, 1961, the Robert Moses Generating Plant and the Lewiston Pump Generation Plant opened. The power project cost a staggering $757 million and was the largest hydropower facility in the Western world. The Moses plant is mammoth, almost 2,000 feet long, 38 stories high, and 580 feet wide. Its 13 turbines are equally impressive. Each turbine is made up of stainless steel shafts, each 50 inches in diameter and 32 feet long, divided into 2 16-foot sections. The sections are joined with 18 6.5-inch bolts that are stretched across the width of the shaft. With the new power plants came new technology. The Moses and Lewiston plants employed a new technique to transport water from the river to the 1,900-acre reservoir.
The tunnel that delivers the water, or I should say the tunnels, we refer to them as the conduits that bring the water from the upper Niagara River, they were completed in a method called cut and cover. 2 trenches were initially dug in the ground, and then they were taken and lined with concrete. And the thickness is, I know the walls are like 2.5 feet thick, the floor is 4 foot thick, and the arch itself is about 5 foot thick. And this was all done in 40-foot sections, and we just moved right down the entire length to complete the construction of these 2 conduits. And then it was backfilled right over with overburden, topsoil, and you wouldn't even know that they're there right now.
Maintaining the conduits has also pushed the technological envelope.
If you think about inspecting a 4-mile tunnel underwater, how do you do it? It's more than you could do with a manned diver. So we've actually done it twice. We've gone in at each end and we put a manned submersible in. And this is a tethered submarine that an individual will be in, and he goes in from each end about 2 miles. And we do a visual inspection plus a camera inspection of the walls, the ceiling, and the floor to look for any problems. We went out and had a specially designed cable built. It's quite interesting. It's a cable which has the mechanical strength necessary to pull the submarine back if it had to. It has electrical feed, obviously, for the electrical equipment on board, and it has fiber optics in the center to bring the video back.
But that's only half the battle in turning water from the Niagara River into electricity for the eastern seaboard. If the canal walls are safe, water that's diverted from the Niagara River will flow into penstocks.
We have 24-foot diameter penstocks, which brings the water down from the forebay down to the generator itself. The generator sits down here in the main powerhouse where the turbine will spin inside a scroll case. The water that's being delivered from the 24-foot diameter penstock passes through the scroll case, forcing the water into a turbine. The turbine acts as a water wheel does, turning the shaft of the generator. From there, the power flows up through underground conduits up into the switchyard. And from the switchyard, it flows out on 21 different transmission lines to various parts of the state.
The advent of the state-of-the-art Niagara Power Project was the death blow for the turn-of-the-century plants. Niagara Falls Power Company powerhouses number 1 and number 2 were permanently shut down on September 30th, 1961, amid little fanfare. Hydropower accounts for 15% of the world's electricity. Niagara Power will return on Modern Marvels. The Niagara power plants had moved easily into the second half of the 20th century, running smoothly, efficiently, all but invisible to the public. But all that changed on November 9th, 1965.
One moment, New York was glittering Gotham, the Great White Way ablaze. The next moment, only flickering candles, automobile headlights, and bobbing flashlights were probing a Stygian darkness.
80,000 square miles of northeastern North America were suddenly blacked out by the worst power failure in the history of the Western world. A small fail-safe device in the Sir Adam Beck generating plant number 2 tripped and sent a power surge of current in the wrong direction. In just 12 minutes, 30 million people in 8 states and the province of Ontario were without electricity. New York City would remain without electricity through the night. Finally, at dawn, service was restored and life went back to normal. The Niagara Power Project remains the largest electricity producer in New York State, meeting 10% of the state's overall power needs. But as its federally regulated license comes up for renewal in 2006, the Niagara Power Project must continue to reinvent itself and its ability to produce electricity.
We're always looking at ways of improving our maintenance. We're looking at what technology can bring as far as improvements to what we have here. Many of the equipment we have, many of it's still original equipment. Much of it's been updated, but some of it is just the basic technologies of the conversion of hydropower into electricity hasn't changed much. So we're looking at all that and trying to keep pace with it and move forward.
Renovation at the Moses plant won't be completed until 2006. It will upgrade the existing 13 turbine generators and will enable the plant to use 6 million extra gallons of water a minute, producing up to 14% more electricity during periods of high consumer demand. On the Canadian side, Ontario Hydro Company, the operators of the Sir Adam Beck plants, are also looking to expand.
The use of the Niagara River is governed by international treaty between Canada and the United States. On the Canadian side, we are not yet using our full potential available through the treaty. Right now, we are actively considering the construction of a new tunnel that would provide more water to the existing Beck power plants.
The tunnel would be built below the existing tunnels and would be more than 12 miles long and 37 feet wide. The project is estimated to cost between $300 and $500 million. It would increase the power output of the Beck generating stations by 12%. For more than 100 years, Niagara Falls has served as inspiration for scientists and lovers of nature alike.
Niagara Falls had always bespoken raw power, and for centuries, people had envisioned Niagara being put to use. And it was the Niagara Falls Power Company that truly did utilize the vast torrents of Niagara Falls.
They managed to construct something that basically changed the world. It set the pace for our modern day life.
The American and Canadian Niagara power plants were the inspiration for today's massive electrical and hydroelectrical power ventures. For centuries, Niagara Falls has been a vision for dreamers mesmerized by the natural spectacle. Today, Niagara Falls power plants continue to delicately balance the fine line between exploitation of the falls and our desire to use the energy that abides there.